Welcome to EDU World Space.
So in this problem, we have a cable that is hanging between two supports. It is under a uniform load that is a uniform function of x. We're neglecting the weight. So there's it's basically carrying something down here through some cables. We know that, let's see here, we're going to use the origin as the minimum of our cable here, which we don't actually know where it is, but we're going to say that's 0. Wherever it is, that's 0. And then we can measure, let's see here, we can measure the x, this point here is some distance xc to the right of the origin, and we know that it's 20 feet above the origin. And this point here, we know that the distance here is, I'm going to call it d. Actually, in the problem it's given as 100 feet, but I'm just going to call it d for now. So the coordinate of this point is xc minus d over here. Okay, so this is going to be a negative value. And we know that it is 40 feet above the minimum point of the cable here. We know that the slope is 0 at this point also, so the function that describes this curve is a parabola, and it's w naught x squared all over 2 times the horizontal force. We can say that w at xc, or y at xc, is 20, and y at xc minus d is 40. And that would give us an equation to find, xc and an equation to find fax. Xc is square root of 2 minus 1 times d, and fax is d squared omega naught, or w naught, over 40 times the quantity 3 minus 2 square root of 2. So we know, we're given this, and we know this, so we can actually calculate values for all this. We have then, if we plug these things, if we plug this into here, we get that that the function is described by 20 times x squared all over the quantity 3 minus 2 square root of 2 times d squared. So that's our parabola, our function here. Now, we are asked to find the tension at point A, B, and C. So we can figure out what the tangent of theta is. The tangent of theta is just the derivative of y at xc minus d. Theta is 0. The angle between the horizontal and the tangent is 0 at point B, and at point C, the tangent and the angle between the tangent of the angle here is y prime at x sub c. So we have all these values, and now we can plug in our, this is going to be a value, so we can figure out what this is. So we can figure out what this is, and then we know that the tension is just fax all over cosine of theta, wherever and at whatever point we're at. So at point A, we'll use theta of A, and we'll get that the tension there is 61.7 kip. At B, this is actually the same as the tension at the support, at either support, and that is 36.5 kip. And at C here, we can get the angle C theta sub C, and plug that in, and we get that the tension there is 50.7 kip.